the iron produced are generally classified as direct reduction processes, and the products referred to as direct reduced iron or DRI. Feed materials for DRI process are either iron ore, sized iron ore 10 mm to 30 mm in size, or iron ore pellet. The direct reduction processes are mainly of two types: dash-based processes, where the reactor is shaped in, reducing gas is dash, which is produced externally to this reactor, and examples are mid-rest and HYA process, while the toll-based process. In the dash-based plant, the shaft furnace reactors works on the counter-current principle, where the iron ore feed materials move downwards in the furnace by gravity, and that's reduced by the upwelling reducing gases. The pressure and temperature in the shaft furnace in HYA process is 5 bar and 800 to 850 degrees centigrade, while in mid-rest process it is 1.15 bar and 800 to 850 degrees centigrade. The product in shaft furnace can be sold as a tolled DRI, hot treated as HBI, and can be transported hot to steel making as HDRI. These are the reactions in a vertical shaft furnace, where the reduction takes place with hydrogen and carbon monoxide, and when it takes place with hydrogen, the byproduct is water vapor, and when it takes place CO, the byproduct is CO2, and this figure shows the reaction taking place. The shaft works on the principle of counterflowing of gas and solids to maximize reduction efficiency. Uniform solids flow is aimed by effective distributing the furnace burden and avoid material bridging. The flow of gases between the various furnace zones is to be controlled. The reducing gas from coming into contact with air oxygen need to be prevented, and otherwise gas will be oxidized. And uniform temperature provided across the cross section of the furnace is to be maintained, and the stoppage of the furnace burden flow is to be avoided. That means the furnace burden flow should be continuous and it should not be stopped during the process. These are the various parameters and specific consumption in gas-based plant. One can see the mid-rest process and IVSR process for CDRI, HDRI and HBI. CDRI and HDRI, what are the metallization, carbon, iron ore, natural gas consumption, oxygen, nitrogen, water consumption are tabulated here. CO gas can also be used as a reducing gas, and this CO gas, the normal composition is this, and after it is reformed, we get this composition of gas, and is very similar to the natural gas, the reformed gas produced from natural gas. If one sees that composition is much similar in nature, and so CO gas, total gas can also be used as a reduction gas in the DRI process. So those plants, steel plants where the total gas is in excess, this gas can be utilized in the DRI plant. These are the features of mid-rest reformer, and one can see the pressure is 1 to 2 bar and exit temperature 930 degrees centigrade for the gas, and there is methane shape of one molecule. This is the mid-rest process, standard mid-rest process, where this is the reformer, this is the reactor, this is the cooler, and these are the preheaters. This is other flow sheets where this is waste heat boiler, heat recovery unit, this is the reformer unit, this is reactor, and there are the HPI production, CDRI production, and hot ring directly going to EF or transported through a vessel to EF or through a conveyor. It is transferred to EF. This is a pictorial view of a DRI, mid-rest DRI plant, where you see this is the building which is housing the reactor, which is the tallest unit in the meter. HPR process, the basic flow sheet is there. This is the gas reformer, this is gas reformer units, and this is the main reactor unit, and this is cooler, and this is the hot transfer of the DRI to the EF, and here the producer gas is heated. This is the HPR process flow sheet. HPR feature of HPI steam reformer. One can see the pressure is 6 to 7 bar is the pressure, and methane slip is 2 to 2.5%, and exit temperature at 43 degrees centigrade. These are the special feature, or these are the features of the HPI3 reformer. This is the flow sheets of HPI process, where this is reactor, this is the heater. Any gas can be used: natural gas, reformer gas, syngas from toll, or CO2 gas, and others can be used. And the external tools for CDRI and hot DRI transfer to EF can be made.